Hello, we are team number 1, and my partner Chris and I, Sofia, are going to present our statistical project about the water quality in Mexico. The content that we are going to be talking about during the presentation is the following. First, we will review the previously talked about scientific and statistical hypotheses. After that, we will see how the superficial scale was made by Conawa. Then we will see how the response variable was built. And once we've done that, we will explain how we transferred the statistical hypothesis to hypotheses suitable for regression analysis. Once we've done that, we will explain how we identified the type of regression to analyze our new hypothesis. Then we will present the code developed in our studio. After that, we will show the interpretation of the regression analysis considering all important criteria. Then we will see the degree of association between the independent variables and the response variable. Then we will show the comparison between the results based on the regression analysis and previously used methods, which were Bayesian and Fisherian approach. And finally, some conclusions. Now, as I've said before, we're going to review the scientific and statistical hypothesis. So first we have the scientific hypothesis, which is if the superficial water has a low content of suspended solids in natural conditions and a low content of organic biodegradable matter, then the water quality of its rivers is considered a good water quality. For this scientific hypothesis, we have two statistical hypotheses. The first one states that the mean of a biochemical oxygen demand during 5 days from the superficial water network of Tabasco is less than or equal to 6 milligrams per liter. So this is what the null hypothesis states, mean less than equal to 6, and the alternative hypothesis states that the mean is greater than 6. The second statistical hypothesis states that the mean of total suspended solids from the superficial network of Tabasco is less than or equal to 75 milligrams per liter. The null hypothesis states that the mean is less than equal to 75, and the alternative hypothesis states that the mean is greater than 75. For the second scientific hypothesis, we have if the superficial water has bacteriological contamination and residual water discharge, then the water quality of its rivers is considered a low quality. The first statistical hypothesis for the scientific hypothesis states that the mean of Escherichia coli, or E. coli, from the superficial water network of Tabasco is less than 850 most probable number in 100 milliliters of E. coli. So the null hypothesis states that the mean is less than or equal to 150, and the alternative hypothesis states that the mean is greater than 850. The second statistical hypothesis states that the mean of chemical oxygen demand from the superficial network of Tabasco is less than or equal to 40 milligrams per liter. The alternative hypothesis states that the mean is less than or equal to 40, and the alternative hypothesis states that the mean is greater than 40. For the third scientific hypothesis, we have the superficial water has a satisfactory quality for aquatic life and recreational use, with primary contact and other uses when there is low indications of bacteriological alteration of the quality. The statistical hypothesis for this scientific hypothesis states that the mean of fecal coliforms from the superficial water network of Tabasco is less than or equal to 1,000 most probable number in 100 milliliters. The null hypothesis states that the mean is less than or equal to 1,000, and the alternative hypothesis states that the mean is greater than 1,000.
As mentioned in previously deliveries, CONAGUA has standards and regulations for the parameters studied. This is the criteria for the monitoring sites that indicates the quality of the water following a superficial scale with different parameters. The response variable of our project is a categorical variable because the water quality can be acceptable or contaminated. It is acceptable when all 5 parameters meet their respective water quality standards, and it is considered contaminated when one of them doesn't meet the criteria of acceptable. Therefore, to obtain the response variable, a conditional was stated in order to make sure that all the criteria shown below was followed. Now we will be working with a discrete variable. 0 means contaminated water quality and 1 is acceptable water quality. So y is equal to 1 when dVO5 is lower or equal to 30, dQO is lower or equal to 40, SST is lower or equal to 150, fecal coliform is lower or equal to 1000, and E. coli is lower or equal to 850. And y is 0 when at least one of them is not in the acceptable criteria. Since the response variable was built using the parameters, we already established that it is a function and there is a relation between independent and dependent variables. Therefore, the best solution and technique is tree regression. However, with our current course knowledge, what we did is a regression analysis where we studied how much y itself is influenced by every single variable, and that is called the degree of association. As it is known, we use all our variables together to build our y. Now, instead of taking all of them in a regression, we studied one by one. These are our regression models and the new hypothesis of significance. Here, our objective is to find the regression coefficient. Here we have our independent variables translated to x. x1 is equal to biochemical oxygen demand at 5 days, x2 is chemical oxygen demand, x3 is total suspended solids, x4 is fecal coliform, and x5 is E. coli. Because the independent variable level is continuous and the dependent variable level is discrete or dichotomous, we did a logistic regression. The model was fit as a generalized linear model in a logic regression because this is used to model dichotomous outcome variables, which mean variables that only can take 2 values. In our case, as we previously discussed, y can be 1 or 0, 1 for acceptable water quality and 0 for contaminated water quality.
Now, we're gonna talk about our code and the setting of the regression model. As Chris talked about before, our response variable is a discrete categorical variable. Therefore, the response variable was fitted as a generalized linear model that is binomially distributed, as you can see here, with 2 predictor variables using the logic link function, which is this one. This means we're doing a logistic regression. Then the number 1 is subtracted in each of our regressions because this is how you remove the intercept from the regression model. Our models are without intercept because the objective of this regression is to know the degree of association of each variable with the dependent variable, which in this case is our response variable. Now we're going to talk about the interpretation of the regression analysis. As we can see in both of these summaries, we can confirm that all of the regressions were done successfully, and we can see that the residual and null deviance in both of the summaries are very close to each other and also very close to the degrees of freedom. We always look also for the AIC to be small. As we can see, it's small in both of these summaries, and also for the number of iterations to be as small as they can be. So this was accomplished in obviously these 2 regressions and also in all of the other 3. The estimate corresponds to the coefficient of regression, or more commonly known as the degree of association that the independent variable, for example in this case dVO5, has to the response variable, which is y. The negative in all of these coefficients, as you can see also in the quote, it's negative. It simply means that the relationship between the response variable and all of the independent variables is an inverse relationship. So this means that as the parameters become bigger or grow, the water quality worsens. Now, to determine which of the null hypotheses we're going to be rejected, we have to look at the p-value in each of the regressions, because the p-value tells us the significance of the value that the value or the variable has to the dependent variable. So for example, in DB05, the p-value is bigger than the alpha, which is 0.05. Therefore, the null hypothesis is not rejected because there is no significance of this variable with the response variable. Then for DQO, the null hypothesis is rejected because the p-value is really small and it's smaller than 0.05, which is the alpha. Therefore, it has a big significance with the response variable. Then for SST, the null hypothesis is not rejected because, again, the p-value is greater than 0.05, greater than the alpha. Therefore, there is no significance with this variable with the response variable. Then for fecal coliforms, the null hypothesis is also rejected because the p-value is very small, smaller than 0.05. Therefore, the significance of this variable is very big in response to the response variable. Then for E. coli, the null hypothesis is also rejected because the p-value is very small, smaller than 0.05, and this means that this variable is very significant to the response variable.
Even though we need additional analysis to obtain what we expected, that is, all variables were rejected in the regression analysis, right now we can talk about the degree of association. We can see, taking into account what we obtained in the GLM, is that, as mentioned previously, the 5 regression coefficients are negative because at higher x the presence of a parameter is higher, lower water quality we have, which means that the water is more contaminated. So the regression coefficient indicates the degree of association of one variable with respect to y. The variable with the highest negative effect in y is DB05, then DQO, SST, E. coli, and finally fecal coliform. This is something expected because studying the dataset of the independent variables, DB05 is the parameter with the lowest contaminated result in our dataset, then DQO, SST, E. coli, and finally fecal coliform. Now, comparing the Fisher and variation hypothesis results with the regression analysis, we can see that the variation and Fisher results obtained in the previous deliveries, they tell us if the hypothesis null is rejected or not rejected based on a specific parameter. It is telling us if the parameter is meeting the water quality criteria established by CONAGUA. On the other hand, GLM regression hypotheses show if a specific parameter has an effect or not on the response variable. In the Fisherian approach and variation approach, DB05, fecal coliforms, and E. coli, the 3 variables have the same results. The 3 rejected the null hypothesis, which means these 3 parameters are not in acceptable water quality standards, while DQO and SST did not reject the null hypothesis, which means they are in acceptable water quality standards. For GLM regression, we obtained that DB05 and SST are not rejected, which means they do not have a significant effect in the response variable, while DQO, CF, and E. coli are rejected having a significant effect in Y. We expected that all the variables individually were rejected. However, we did not obtain that. This can be because in our regression analysis, as mentioned before, we are testing different models individually, and in linear regression models, the more variables we have, the more significant the model is. but not necessarily individually the variable will be significant. In conclusion, the linear regression analysis for our dataset is not the best technique to make decisions. This kind of regression only can tell us the degree of association of each variable with respect to y. With this kind of analysis, it's a little bit complicated to fulfill the purpose of a regression analysis, mainly because for this kind of dataset where the response variable is already a function of the independent variables, a different technique is needed to learn from the data to provide additional information in order to make decisions based on this analysis. That is why we think a machine learning approach like a decision tree will be better for this kind of data, or additional analysis like kappa statistic analysis, which is a statistical measure of integrator reliability for categorical variables. Thank you so much for your attention. That was all for today.